Hi there, this is video 7.8 and we are going to use Desmos to look at the standard form of the quadratic equation, which is the one with the ax squared plus bx plus c. So I would like you to use your phone or tablet or laptop and go to Desmos, and I will meet you there shortly. Oh, good. It worked. This is about the third time I've done this, and well, let's just say the first ones weren't very successful. Here we go. Y equals ax squared. Whoops. See, you gotta watch for that. You gotta remember not to put 2 like that. You need to use the keypad. All right. Plus bx plus c. And then it'll give you the option for the sliders, and you say yes to all of them. And then you say b equals 0 and c equal to 0. Okay, so it's one of those weird things where you're going to look at the screen and you can write on your sheet as we go. So use the slider to see what happens as you change the value of a. And it looks like it does exactly, what it did last time. Right, if it's positive, oh, it goes negative, and it flips, and yeah, it does exactly what it did before. So in general, as a increases, it's going to get narrower and narrower. As a gets closer to 0, it's going to go wider, shallow and narrow. I call it shallow. It's going to be more wider. So if a is little, it goes like this. Sorry, if a is big, as a gets smaller, it goes like this. And when it starts to go negative, it does the opposite thing. And the cool thing is that what happened with the vertex form? Yes. So it doesn't matter whether you're dealing with the standard form or the vertex form of the quadratic equation. A does the same thing. So one, and most importantly, determines whether it opens up or down. And then it also tells you if it's going to be kind of a wider and narrow one. All right, use the slider. Oh, let's put this back to 1. So that's our standard. Oh, close enough. There we go. All right, now, I'm going to do one more thing. And you guys can do this when you're working with Desmos if you want. I should have done that straight. There. Come back here. Back to 0 for you. All right, there. Now it's nice graph paper. Now I want you to change the slider for B. And as we change B, ooh, well, that's kind of weird. Look at that. I'll just play that over for you. So 2 things happen when you change B. Not only does it go up and down, but it also seems to move sideways. Let me just stop that for a sec. So what 2 things? But the key question is what doesn't change as you're doing this. So take a look. What value seems to stay constant? It's at 0, 0. Okay, and it is the y-intercept. So the y-intercept remains constant, and we'll see that in the next part. Okay, let's put this back to 0. Oops, I need to stop. Where'd you go? Back to 0. And if we move C, you can see C moves it up and down. Now, I want to show you both. You better write that down. Moves parabola vertically. All right, so if we put that at C at 2, and I'm going to run B. You see what I mean? It's actually the y-intercept. That point remains constant, whereas all the other points on the graph move. It just keeps going up and down like And if we make a, let's make a negative, go negative 2. And you know what? Like that. It does exactly the same thing, whether it's opening up or opening down. Whatever that value is of C, which is my y-intercept, that remains constant. I think that's pretty cool. All right. What relationship, do you see between the value of C and the y-intercept? Well, if I move C, let's make C up to 5. And look, there's your y-intercept. And if I move it down to -4, there's your y-intercept. So C equals the y-intercept. And there we go. That is the end of the video on the introduction of the standard form, video 7.8. And something's wrong with my turn off of it.